Okay, great. Well, so thanks again for everybody joining on Zoom. And this is Bryant Park B Wednesday. This is our third session of the day. We've got Mr. LJ LongWing, BMC Software. Most of us know him, and if you don't know him, you're just about to. He's got a presentation here on managing containers for BMC Helix Innovation Suite through the console and the REST API. So without further ado, I'm going to turn it over to LJ. And if you, am I sharing? Yes, you're going to stop. Okay, stop sharing, and you should be able to share, LJ. Okay.
Okay,
it's up here.
There we go. So when I was thinking about setting up a presentation for this meeting, for the last 10, 15 years, I've been focusing mainly on integrations. How do I get one application to talk to another? And predominantly the technology that is being used by everything I've been doing for the last 10 or 15 has been REST. So when I started talking about, do I want to do a presentation for today? I thought, what can I talk to? And the topic of the day obviously is Kubernetes. Everything's moving to a container orchestration layer. Everything's moving into containers, and Kubernetes is the orchestration layer we're choosing. So I thought it'd be really fun, being Kubernetes is the one that is pulling the puppet strings on Remedy. It'd be really fun to have that puppet reach out and pull its own strings. So I decided to build a console that allows me to talk to Kubernetes, see what Kubernetes has, see what Kubernetes is configured to do, and where appropriate, reach out and pull the strings to change some things. So that's what I'm looking to do today. We're going to be talking about Kubernetes and the Remedy console, why Kubernetes, and why are we wanting this console in any shape or form. So Kubernetes is container orchestration. For those of you that have not already heard that term 5,000 times this week, orchestration is the simple ability to say, here's all the containers I need to run, here's how I'm going to configure them, and here's how many of each one I'm going to configure, and I'm going to monitor them, I'm going to start them, I'm going to stop them, I'm going to manage them appropriately. Okay. It allows for quick and easy deployment of containers, and it allows for easy scaling of containers. Kubernetes is, as you have probably all heard, I was really happy to have Robin, the session we just attended right before this one, moving to Kubernetes, because he was talking about a lot of the same stuff. It's environment agnostic. It doesn't matter if you want to run your own container or your own Kubernetes. It doesn't matter if you want to pay Google to do it, or if you want to pay Microsoft to do it, or if you want to pay Amazon to do it. It doesn't really matter whose Kubernetes environment you're running in. It's the same Kubernetes. It's the same platform. It's still going to run the same software flawlessly, ideally. So it really doesn't matter where you're running it. Alternatives to Kubernetes, when BMC started down this road, as I've heard countless times, Kubernetes is what we're using internally. When we started talking to customers about it, OpenShift was the one that at least one of our customers said, we've already got a containerized orchestrator out there. We're using OpenShift, not Kubernetes. So BMC came along and said, okay, we'll support that as well, increase our diversity a little bit. So OpenShift is currently an alternative. If you go 3-5 years down the road, I'm certainly not on the road mapping team. I don't know what's on the roadmap, but I can certainly see that the alternatives to Kubernetes and OpenShift will increase the more flexible our implementation becomes. So those are the two main pieces, and two main players in the market, but I can totally see the alternatives to those being significantly greater down the road, but who knows? Now, Rancher, does anybody in the room know what Rancher is? Okay, so
we have them in Texas.
Rancher is a Kubernetes orchestrator. So if you think of Kubernetes as an environment, so you're going to set up a Kubernetes cluster, and that's going to be your prod cluster. Then you're going to stand up a test Kubernetes cluster, and you're going to stand up a dev Kubernetes cluster. And each of these three clusters are going to have the full Remedy suite sitting in it, running with its own configurations and such. Well, managing multiple Kubernetes clusters can become difficult. So Rancher is a layer on top of that. Then it allows you to manage multiple Kubernetes clusters. So in a single interface of Rancher, you can actually say, I'd like to take the configuration that I've just finished setting up in dev, and I want to migrate that configuration to test. And it will take all that configuration that you did over here, move it into the test system, and then you can verify, yes, that configuration is going to work for me, memory, CPUs, all that sort of stuff. So it's an additional layer on top of Kubernetes that you can use to help manage things. Okay, but that's why we're talking about Kubernetes. Now, when I was putting this slide together, I've always loved this particular graphic. First time I saw it at BMC, it was the the hand of God. Was it who was that artist that did the Michelangelo? But this one is BMC reaching out to the digital world in that same thing. So I thought it was appropriate for this particular console because it is, if you think about the thing that is managing you in this Kubernetes world, it is Kubernetes that's managing you as the Remedy system. So this is an effort to reach from inside up to the divine orchestration layer and help manage it a little bit. So really what this console is doing is it is a proof of concept to prove to you how you can do the management that you might possibly want to do. It doesn't do everything it's capable, obviously, but it allows you to understand the concepts of how to pull information out of Kubernetes, look at what information you have, and how to actually reach back out to Kubernetes and tell it, I want to make these changes. This particular demo application is it's using the Apl Restful Plugin, which I wrote, available freely on my website for any of you that are not familiar with it. I'm using this because the out-of-the-box Remedy REST capability does not allow for the REST methods that I need to be able to use to be able to make the changes in Kubernetes. All of the stuff of get information out of Kubernetes was fully functional. I built a version of this console that was using out-of-the-box REST capabilities. It did all the gets beautifully. I was able to pull all the information I needed. I was able to display everything in console the way I wanted, but the piece I was missing was the ability to actually reach back out to Kubernetes and make that change. So I rebuilt the console completely using my REST API. It's all very simple stuff. Anybody in here not used REST to communicate with an external system? No hands went up in the room. Good. So this particular integration is using two methods. One of them is a get, which obviously is a retrieve information from remote system. And the other one is a patch. So I'll discuss patch just a little bit because it's not the most common REST method to use. When dealing with RESTful methods, there's two of them that are generally used for update the remote system. The most common one is a put, and then there's the patch. The difference between a put and a patch is a put says, this is my wall. Here are its dimensions, here's how thick it is, here's its angle, here's everything about the wall. If I want to add a window to that wall, using a put method, using the strictest definitions of how REST is supposed to work, I have to define not just the definition of the window itself, but I have to redefine the wall as well. I'm replacing the existing wall definition with its existing dimensions, its existing structure, but I'm adding into that structure a window. If, however, I want to take the existing window and update the existing wall and update that wall to include a window, I would use a patch. So a patch method says, don't change any structure about your definition other than what I am changing in my definition, in my update. Patch is a lot smaller and it's a lot more concise as to what it needs to do. And Kubernetes fully supports patch versus post, or patch versus put. And if I had wanted to do a put, as I said, I would have to define the entire wall, including the window. Kubernetes supports that, and I could have used the out-of-the-box remedy workflow because it supports put, but I didn't necessarily want to be including the entire structure of the entire service that I was modifying. I just wanted to modify the one little piece. So if you are interested in using the out-of-the-box does support put, and you can do it. It just requires the entire structure of the object you're changing instead of just the one little piece. So that's why I chose to go with my custom plugin instead of the out-of-the-box. In this particular demo, Kubernetes uses a user token. So as opposed to, say, a remedy token, which expires after 2 hours or something like that, when you define a Kubernetes user and token, that is permanent. So the token that I'm using in this particular demo is a namespace admin, which means that this user has permission to do everything within the namespace it needs to do, from a pod to just all the structures that I'm going to be demoing today. If you want to be able to do additional work, such as get a list of what nodes are available in the Kubernetes cluster or manage what nodes are available in the Kubernetes cluster, you would have to have a user token from a cluster admin, not a namespace admin. So I want to make sure that you guys understood that definition, and the token I have is very namespace specific. So does anybody understand, or does anybody not understand, I apologize, what a namespace within Kubernetes is?
So is that what you're installing everything into? Is that kind of your group?
Yes, so a Kubernetes cluster is just a large box of nodes. And a namespace has specific resources within those nodes. So within Kubernetes, you can say, I'm running remedy, so I'm going to create a remedy node. And, a remedy namespace. And then you might also be running your web server cluster in Kubernetes. That's not related to remedy, but a different application. You can create a separate namespace for those applications, and you can create as many namespaces as you need, but each namespace has its own little world. So in our case, when you're installing remedy and containers, you're specifying, here's the namespace it's going into, and that's the only thing that you can touch. All the communication, the IP addresses, the open communication between services and between AR server and mid-tier and all that sort of stuff, that's all open within that namespace. But when you leave that namespace, you have to do ingress controllers, and you have to open ports. And so if you're wanting one namespace to talk to another namespace, you have to do other things. But within a namespace, it's all fairly open communication. I'm probably getting that wrong because I'm not a Kubernetes admin, but that's what a namespace is.
So is everything, all your resources, is that all within a single namespace? There's talk a lot about Kubernetes, you expand and interact. And
all within that namespace. And other namespaces have resources that are allocated to them within the cluster. And then, as I was describing before, you've got the prod cluster, and you have the test cluster, and you have the dev cluster, and as Daniel pointed out, and the UAT cluster, and the testing cluster, and you've got all these clusters that you're going to want to set up. But the namespace is a subspace within the cluster that is specific to your application. In this case, remedy.
BMC actually sets up 3 namespaces for their deployment. There's one for the ADE component, and one for the other stuff. So you don't have everything in one namespace.
Well, the ADE component is that's a good point. ADE is actually a shared component that's not part of Remedy, but is used by Remedy. So when you start talking TSOM and some of the other pieces of BMC software, they're going to be using that component, which is why it's in its own namespace, because Remedy needs to talk to it, but TSOM needs to talk to it, and all the other applications need to talk to it. So that is its own space, and you are 100% correct. I don't consider that part Remedy. But things like the Helix dashboards go in there, because the Helix dashboards is cross all of the platform.
RSSO's in there, a lot of the other, yeah.
Yeah, and RSSO is also
shared components of it.
across all the platforms. So yes, a lot of that sort of stuff is going to be shared services across all the Kubernetes capabilities. So yes, definitely. Okay, now I was demoing this application to a Kubernetes admin that we have inside BMC last week. And he looked at it and he's like, that's great, but why? He said, all this stuff you're doing in this application, I can do really easy at a kubectl command line. I said, yeah, I'm not a Kubernetes admin. I don't know the kubectl command line. I don't know how to do any of this stuff at the kubectl command line. He said, well, your audience must be Remedy based, not Kubernetes based, because if they were Kubernetes based, they would easily drop to a Kubernetes command prompt and do anything you're trying to do here. And I said, that is 100% correct. The audience I'm building this for has nothing, they don't know Kubernetes.
And I don't want to.
And they don't necessarily want to. So I thought that that was very poignant, talking to a Kubernetes admin. Why are you even doing this? So when I was discussing that, I said, really, the reason I want to be able to do this is because I'm Remedy centric. And when I think of integrations between applications, I think of the trigger. Where is the trigger? Who's pulling the trigger on the gun to make the change happen? And quite often, Remedy is the focal point of all the communications within your infrastructure. You've got network automation systems, you've got network monitoring systems, you've got all sorts of systems out there that are opening service requests, they're opening incidents, they're opening problems. Remedy is the focus of a lot of that information. And if you collect the right information, you might say, Remedy needs a new mid-tier. Resource allocation on the existing pods is overtaxed. We need a new mid-tier. So the network automation team might recognize that, and they might open an incident or a problem against that situation. Well, with this console, you have the ability to fire workflow to say, I need to increase my mid-tier counts. And have the network automation team open a ticket, have Remedy increase the mid-tier node count automatically. So why do I want this console? Automation. We all know the workflow. We all know the power of Remedy. Everything's coming into Remedy. So why not use Remedy to help manage the systems that are managing Remedy? So here's where I actually start doing something. This is the console that I've put together. Doesn't look like much, but it's got lots of capabilities here. So within Kubernetes, you have services. Services are the things that the external systems talk to. So when we're taking a look here, we've got OpenFire, which of course is the chat solution. We've got mid-tier for the internal, mid-tier for the user. We've got platform. This is the back-end platform. We've got the FTS server. We've got these services that are visible outside of the Kubernetes cluster or outside of the namespace. So this table right here, it just made a REST call when I clicked on it. It made a REST call out to Kubernetes, got the list of current services available. And then as I'm clicking on each of these individual services, you see that it's refreshing this service ports. So the definition of the service platform -FTS has these ports. This is the AR monitor port, this is the Jetty port, this is the FTS port, CART, AR server, JMS. These are all the ports that are defined within that service. Pods. You guys are familiar with pods? Anybody not know what a pod is? Okay, so a pod is a place that Kubernetes runs a container or one or more containers. So you could think of this almost as a virtual machine in the legacy world. Okay, so a pod is going to be an implementation of, it's going to be what's behind the service. So if you think of a service like a load balancer, you got a load balancer for mid-tier, you got a load balancer for AR server. Okay, this server that is mid-tier user, that's going to be the front end for the servers that are running on the back end for mid-tier. The platform FTS, that's going to be the front end for the pods that are running on the back end that service the requests on there. So you can see here that I've got 2 APL REST pods. That's my plugin server that does my APL REST calls. Okay, I've got an OpenFire pod. I've got some Smart IT pods. And I've got a platform FTS pod. This is platform FTS-0. Okay, so if I were to stand up a second platform FTS environment, it would probably be platform FTS-1. That's managed by the configuration, but it's managed by Kubernetes. Okay, I can look at this platform FTS-0 and I can see. Yes.
Are these related to the item you have highlighted at the top, or are these completely independent?
This list is completely independent. So the question was, is this table related to this table? And the answer is yes and no. This is a completely independent list of the table above. So when I select a record here, it doesn't select a record down here. But these are the pods that feed into those services. So yes, they are related, but not directly tied to each other.
Okay.
Now, when I select the pod, I see a list of TCP ports that are open on this particular pod. And I see a list of environment variables that are available as part of this pod. Now, one thing I haven't shown you is that I can actually double click on any of these tables and it'll drill down into the detailed record. Obviously, there's a lot more detail that exists for a particular configuration than the few columns I chose to show in this table. Okay, but we can take a look at this pod and we can see it's this particular pod's IP address. We can see what app it's associated with, platform FTS. If we take a look at the service that is platform FTS, we can see that it is also part of the same app. So you can scroll through here and you can see all sorts of really useful information. Like I brought some of the more useful things to me and this demo to the top. When did this pod start? Is it started? True. Is it ready? True. Because obviously, as we know from a VM perspective, just because the machine is turned on doesn't mean that it's ready to do what it's supposed to do. So the definition of is it started versus is it ready are different from each other. But these are all of the JSON elements that were brought back by my call to Kubernetes. So there's a lot of information available on each of these pieces I'm looking at here. And again, these are the ports that this particular pod has open, and these are the environment variables that this particular pod has defined. So we can see here from a AR_DB_server_name is Postgres. Okay, so we know that that is the name of the database server it's connecting to. And if we took a look up here at this service, this is the service that that pod is going to be connecting to, the Postgres service, to do its work. Okay, so you can correlate back and forth between services and pods to get various pieces of information for correlation. Now, I've been talking to a lot of people this week. Where is this stored? How does it know that? So it's a generic, the entire container is a generic container that has to be flexible enough to run everybody's configuration. So all the things that in your VM you would normally configure, how much memory is available to this AR server, what port is it running on, what is its password to connect to the database, what database is it connected to, all of this information has to be passed into the container somehow. So containers have a starting point, which is defined when the image is created, that says, here's the script I'm going to execute to start. If we're talking like a mid-tier environment, that's going to be in the Tomcat bin folder, and it's going to be the startup.sh. And Tomcat is going to do whatever it needs to do. And of course, that container, that image is pre-configured with the version of mid-tier that you're running. So when Tomcat starts up, it has what it needs to do, but we're passing in environment variables along the lines of, what is my mid-tier application password? Because even if mid-tier is pre-configured, it needs to know what's my server and what's my password. So that goes in via environment variables. Now, there's a lot of this points at this, points at this, points at this type of thing, because you don't want to have to define what is my mid-tier application password 30 times. So you store that in one place and everything references that one place. So one of the places that you store things is the config map. This is a structure within Kubernetes that allows you to define the configuration that you want to use. While I was working on this demo, I came across a problem where the plugin I was calling was not logging at the level I needed to log at. I went to the BMC docs because that's where you go to figure out how you change your log level. BMC docs said, go to your file system, go to this file, this plugin server XML file, edit that XML file, and change it from info to debug. Sweet. I log into my AR server, which is a pod in my Kubernetes. I go to the directory, it says, there's the file. Sweet. I open it up using VI. I go to the line I need to. I change that line from info to debug. Save. Error. Not writable. Why not? I'm logged in as root. Why can't I write to it? I exit out. I tried changing permissions on the file so that everybody could write. You're on a read-only file system. How am I supposed to modify this XML file if I can't write to the file system it's sitting on? Remember, the file systems within containers are not real. They're, as I believe Robin referred to, you need to think of them as immutable. That file doesn't exist in the image that was provided by BMC. It's provided via a configuration that was passed into Kubernetes. And when Kubernetes spun up that pod, it grabbed that configuration and created the file. So I worked with my Kubernetes admin and I said, hey, how do I modify this? And we went through process of tracing the reference of reference all the way back. And it ended up being a config map. I think it was one of these config maps. And what we ended up finding here was this particular config map. What is that? it's a bunch of Unicode characters to make sure that everything is escaped properly. But if you run this through a Unicode converter to convert it back to normal, what this ends up being is a XML document. All I had to do was go into this config map, find the line in this XML document that I needed to change. I changed it from info to debug and said, update. Immediately, my plugin started logging at debug instead of info, because I told Kubernetes my config map is updated. Kubernetes said, let me notify the pods that are using this config map about that change. And I immediately went into the thing, went back into that config file that I was seeing at the OS level, and that level was changed from info to debug. So understanding the references, the relationships between how BMC is providing the inputs into the pods and how Kubernetes is reading those and translating them into actual configuration at the pod level is really important for being able to understand why things are configured, or possibly in the case of troubleshooting your environment, you need to do this thing, being able to modify that config so that you can do what you need to do. So the other one, the other place you store things is a place called secrets. Secrets are where you store things that you don't want sitting around in plain text. Okay, like remedy application service passwords. Those are important. They still need to be referenced because, again, that image does not know what your remedy application service password is, but it needs to be able to respond to it. So that password has to be stored somewhere in your Kubernetes so that when the pod is stood up, it knows what its remedy application service password is. Your plugins need to know what your remedy application service password is so that they can connect to the AR server. So it needs to be stored somewhere. So when you're looking at the secrets, we see one called Platform FTS. So these are all the secrets for Platform FTS. If we look in here, we see AR server DB user password. That's not the password. That is a base 64 encoded textual string. Okay, so what I can actually do here is I can go out to a convenient website and I can paste my base 64 encoded string. And the string that comes back is AR system. So I now know that my AR system password, or that my remedy application service password in this environment is AR system.
It doesn't seem very secure.
It doesn't seem very secure because you're a root, you're the owner of this system, so you're able to see what you need to see. This console that I built has absolutely no permissions on it. The password, the token that I'm using is a admin of the Kubernetes namespace.
But even so, an admin of the Kubernetes namespace, I don't know if you want him having your passwords. They can get to your secrets. Yeah. Seems like it should be at least encrypted or something.
Many years ago, I was dealing with a Tomcat install, and it was trying to be secured. So they wanted to secure the key store for the certificates. And the default password for a key store is change me. Well, of course, you change it to whatever the heck you want to change it to. But then when you go into your Tomcat config and
you obfuscate it there too, right? But it's still...
You type your password for your key store into your Tomcat config. And I was like, that's not very secure. So I started looking, why isn't that obfuscated? Why isn't that hidden? And the answer that was most predominant on the internet when I read it was, it's on a secure file system in a secure network, in a secure file.
Yeah, the security doesn't apply that. It's not those.
And Tomcat needs to know what the password is. So if Tomcat needs to know what the password is, Tomcat being an open source piece of software, regardless of what encryption algorithm you use, that encryption algorithm is known to the people that want to find it. They can just go look at the source. So you can obfuscate it 15 times if you want, but Tomcat has to reverse every level of encryption you use in order to provide that password to the key store to be able to get into it. In the end, your key store password is clear text, no matter how many times you obfuscate it, because it's possible to get the clear text password. In this particular case, Kubernetes, in their secrets, they base 64 encode everything. It's not an encryption, it's just encoding, so that the average layman who is looking at the text isn't seeing a clear text password. I consider this better than Tomcat's security of your key store password.
Well, Tomcat, you can XML code. You kind of do the same thing.
But at the same time, it's not an encryption. It's just a obfuscation. So in this particular case, this is an obfuscation. And it's only accessible to the people that have access, rightful access to it. In this particular case, this secret is available to this console because I have a security certificate or a token of somebody who is the namespace admin, which is the same access that a Kubernetes admin to my namespace would have at the kubectl command prompt. Anybody at the cluster level or above would have the same access. I imagine there are lower level accesses that wouldn't have access to passwords or to the secrets. But in this particular case, my user that I'm using to get this information has access to the secrets, and it is obfuscated. But the fact that everything's base 64 encoded, there's nothing plain text in here, but Kubernetes has to be able to get to that information and provide it as a reference into the AR system pod so that the AR server can know what its password is. Now that reference of how the AR server does it is the AR server gets told you are in a secret called platform FTS in element AR server remedy application server's password. So even in the environment variables for the pod itself, it doesn't have in clear text what it is. It just has a reference. I'm just showing you the end point of that reference up the chain of where it sits. If you're implementing this console in your system, you may not want to expose the secrets as a thing that is visible to the main console, if you even want to expose the console at all. Because as I said, the point of this particular console is not necessarily you going in here and using the console, but really automation, workflow to be able to go grab what it needs to grab and change what it needs to change. So you might not actually even use the console that I've built. You might just use it as a reference point of how to get the information necessary to make the changes that you might want to make. So there are a couple of different ways to get information into Kubernetes. One of them is through deployments, and that's the primary method that we use through Jenkins to deploy information into Kubernetes. And there are two other pieces of structure that are referenced by various other structures. Deployments generally control replica sets. Either replica sets or stateful sets are in control of pods. So you can see here from platform FTS, its owner is a stateful set of platform FTS. Or sorry, a stateful set named platform FTS. If I go over to the stateful sets and I look at platform FTS, this is the thing controlling platform FTS, which in my environment is the one and only AR server that's online. And these are the configuration parameters that are configured that are defining when a pod gets stood up. This is the information that is going to control how many pods are stood up and what their configuration is. And the one I want to show you today is the ability to change, the only one I built into this console was the ability to change how many replicas of a particular pod are currently configured. So I'm going to do that. Well, I was originally planning on doing it with the AR server, but when I talked to one of my Kubernetes admins, he said, yeah, don't do that. I said, why not? He said, this namespace doesn't have enough memory and CPU for you to stand up a second Remedy server. So if I were to tell Kubernetes to start up a second Remedy server, it would try. It would run out of memory, the pod would fail, it would keep trying, it would be an ugly mess. So he said, don't do that for your demo.
You have a way to see what resources are available, so you know whether how much is going to be required before you make the change?
If we're talking about platform FTS, let me find that real quick. So we've got, let's see.
You were talking within the namespace itself, right?
Right.
You wanted to know how much of the namespace was still available.
How much of the namespace is still available? No, I don't have access to that.
But you're kind of shooting in the dark and you say, hey, go do this.
Well, I am, because I don't know what namespace, I don't know the resources available to this namespace because I'm not a Kubernetes admin. I'm just a Remedy dude sitting here pushing buttons, seeing, pulling levers and pushing buttons and see what I can do. When I was talking to him, he was like, yeah, there's not enough resources allocated to this namespace, let alone in the cluster, because this is just a sandbox.
I guess my question is, you're saying to use this for automation so that when you see your resources are going low, the automation can come in here and make the correct changes to add your additional mid-tier, for example. How does it know what if those resources are available for you to actually create that second mid-tier?
I'm going to say that the information is there within the namespace. I want to say the information is there.
You'd have to construct another query and probably another console like these do in order to represent the data and then do lookups against it.
I would have to figure out where that data is being stored as far as how many resources are available to this namespace in total. And then probably out of that pod list, pull out the information of how many resources are currently used by each pod and do some sort of summing of that to determine from a CPU and a memory capacity, do I have room to stand up another one? The information's there. That is not something I built in here and not something I even researched while I was looking into this, but all information that's available to Kubernetes is available through this API. When I was building this, I was trying to issue some of the API commands for, give me a list of the nodes. And it said, no permission. Because my username doesn't have permission to see the node list. If I was a cluster admin, I'm sure I would. But I'm a namespace admin, so I don't. So depending on what permission you're able to get out of your Kubernetes people, you may or may not be able to do some of the things. And I'll make note of this now. I kept it in the back of my mind because it was a question one of the people asked me. They said, you're not giving this to end users, are you? And I said, yeah. And they were like, they're not allowed to manage Kubernetes? And that's when I realized that the focus I had in my brain was an on-prem Kubernetes run, where it's your Kubernetes. So you do have permission to look at and modify your Kubernetes environment. He is from the SaaS team, where the Remedy user does not get control over their Kubernetes. They don't control how many pods are running. They don't control any of that. So I'll make that point now, that this is an assumption that you're trying to put this console in a system that you're allowed to manage.
Well, but you know, in the same way, if you're going to back up a database or you would take a copy and you're not a DBA, which I try not to be or have access, I have to say, hey, DBA, how much disk space is available? Oh, you've got so much. Well, how much you can eat? Well, I can't. Can you increase it? So it's similar kind of communication. Is that correct?
Certainly. I mean,
Okay.
the intent of this is not to obviously, run amok in your Kubernetes environment. The knowledge of how much resources are available to the cluster and how much are being used, that's useful to know whether or not I can spin up a new pod for mid-tier. But in my brain, when I'm thinking about this console, I'm thinking about, I think it was Robin's session right before this, where he was saying that during reporting time, you spin up the number of reporting nodes from its default of 5 to 10 to increase capacity while you're needing it at the end of the month, and then at the end, after that, you spin it back down. Well, obviously, you're not going to take it from 5 to 10 unless you have resources to take it from 5 to 10. The same sort of assumption was going on in my brain while I was building this. I'm going to know my environment. I'm going to know my capacity. I'm going to know what I have the capability of doing before I do it. Now, obviously, if I was spinning up the AR server without knowledge that I didn't have enough resources for AR server, I'd see the pod start, not become ready. I'd see it crash. I'd see it destroyed. I'd see a new one stand up. And I'd be like, what the heck is going on? Talk to my Kubernetes admin, and you don't have those resources. You can't start that. So the thing here that I'm going to do is, because I don't want to screw up my environment, I'm going to take this mid-tier user. And I'm going to see that this mid-tier user is controlled by replica set mid-tier user 6 something or other. So I come over to this replica set, and I find that replica set that is controlling my mid-tier. And I look at this replica set and I see that it's managed by a deployment called mid-tier user. So I come up to my deployment for mid-tier user, and I see that there is currently 1 replica assigned, and there's 1 replica available. If I hit 2 and hit update replicas, my mid-tier user is now changed to, I'm configured to 2, and there's 1 currently available. If I come over here and say refresh pods, I now see 2 mid-tier users. Both of them are started, but only one of them is ready. So Kubernetes took the configuration and said, well, I need 2. So it passed it down through the replica sets, which is now updated to 2. It also knows there's only 1 available. And if I keep refreshing my pods, eventually this line is going to change from ready false to ready true. And when that happens, my replica set and my deployment numbers are going to change from ready 1 to ready 2.
So you're creating another user mid-tier.
With a single button press, a
Wow.
single action, I'm duplicating the number of mid-tiers I have in this environment.
Downgrade it the same way.
Downgrade exactly the same way. So now I've got 2 mid-tier users, and I can see that this is the one that just started, because it started on 12.8. It's also controlled by the same replica set. And if I come back over here to this, instead of saying 2.1, I've now got 2.2.2.
And it's ready as true over there on the pod.
Yeah, and if I check here, I'm configured for 2, and there are 2 running. If I want to downgrade that from 2 to 1, I just change that to 1 and hit update replicas. If I come over here and refresh this, when Kubernetes finishes doing its communication, it's going to decrease the number of user pods available back down to 1.
So did it actually go out and spin up another virtual machine?
A container, yes. It grabbed the image out of the Harbor repository. It changed its configuration. It grabbed all the environment variables out of everything that it needs to do, and it spun up a new container. And I now have 2 containers for mid-tier user.
And the load balancer automatically know, hey, I got another one, so let's start sharing here as well.
It does, because the mid-tier has an ingress controller in front of it, which is the internal load balancer. The service was updated to notify, I've got 2 mid-tier instances now, and it starts load balancing against them.
Does the SSL certificate go with that, or is it simply at the load balancer?
The SSL certificate in this version that we're looking at right now is actually offloaded to the F5 load balancer or whatever load balancer you have outside of it. Right, so SSL isn't handled inside the containers from that perspective. But in the most recent refresh that I did here, we see that we've only got 1 mid-tier user again. And if I refresh this, it's all back to 1. If I refresh this, it's back to 1. So that is the only change I have configured within this application. But any configuration that you want to change in your Kubernetes can be managed through workflow with the proper configuration in a REST client to make the proper pushes.
So would you consider this server group console on steroids?
Sorry?
Would you consider this server group console on steroids?
Yes and no. It is a puppet pulling its own strings, is how I like to think of it.
Maybe something you might want to add some capabilities to the server group console to be able to manage stuff like that. I could see, like you said, if you want to give admin capability to people, you probably want to make it a little simpler than this, but to say spin up another mid-tier or something like that.
I'm looking for the goal here.
Yeah.
The goal of this to replace the server group console.
I don't think
is
it'll replace it
something
because
that
you
will actually.
You
take
still
care
have a lot of
everything.
stuff going on in the server group console, like all your centralized config and stuff that way, but this is more to manage Kubernetes, right?
Right. This is solely to manage Kubernetes, and things that you can manage are like, how many CPUs does the pod have available to it? How much memory does the pod have available to it? Within the environment variables, you have how much heap space is your AR server going to be running? That's an environment variable that you can pull and modify as appropriate. Obviously, if you're changing heap space on a JVM, that's not an on-the-fly change. That's going to be something that requires a restart of each of the pods in order for it to take effect. But you have the ability of modifying that through a console like this and allowing Kubernetes to do what it is Kubernetes is supposed to be doing to keep your environment available.
But it's going to require, 1, your REST API stuff that you got, 2, you've got to have a Kubernetes account that has permissions to do whatever action you're trying to do. They can log in with that and make that REST call to do it.
There are a lot of dependencies that make this function.
So you, like you said, in your world, your Kubernetes admin may not give you an account with permissions to be able to do some of the stuff that you want. Is the way to.
Correct.
So if you're going to do an on-premises thing, you got to go hire a Kubernetes admin.
It would be recommended.
Okay.
And you have somebody to maintain your Kubernetes environment.
Yeah, the question was, is BMC expecting you to have a Kubernetes admin if you're going to be running a Kubernetes cluster on site? Yeah, you should have a Kubernetes admin, just as in the same way that you have a DBA.
And To be honest with you, BMC is not giving you guidance on that level of detail. We're all looking for it.
Oh, that's why I asked the question.
Yeah, you need to have a Kubernetes person to give you guidance on how to set it.
I'd rather use it.
So when you're interviewing the Kubernetes admin, just make sure they know that their job is dependent upon you having access to your account and these permissions.
And the only comment during this entire thing in the chat was that auditors thought it was funny I was using the Remedy user tool.
Yay.
If he hadn't said it in the chat, I was gonna say.
I verified that this console was fully functional in mid-tier, but Remedy user is just, I'm old school, so. Are there any other questions regarding, no. Any other questions?
I have one last question about this presentation, about this form. So you just admitted that you're still using the user tool, but how did you build this? What version of is this the new Innovation Studio presentation, or is this a more of an AR admin?
This is an application that is using technology available all the way back to 7-ish.
You've got a table on there.
Oh, yeah, right, yeah.
But this is making a, well, I say it's making an assumption. This is managing the AR server, or it's managing the Kubernetes cluster that this AR server is running in. So this is running on 21.3. It could run all the way back to 21.02.
But did you create it?
I developed this in Dev Studio on a 21.3 server, but the technology it's using is not a converged server technology. This is Dev Studio with Remedy user.
Okay.
But you also have to configure your plugin inside of that Kubernetes environment, right? So that's kind of a little bit of a pain too, isn't it? That could have been another lesson.
Having used his Apl rest thing?
Yeah.
It's not.
No, it's not in a normal Remedy environment, but like you said, everything's ephemeral and
So what we had to do to answer that question, in order to get my plugin functional in a container environment, my plugin had to be containerized. There's documentation on the BMC website about how to instantiate a custom plugin in the containerized environment. So we basically took a shell and we put my plugin in that shell and we uploaded that image to a hardware registry. We configured a Helm chart that specified all of the proper information. And then we deployed that Helm chart through Jenkins into the Kubernetes cluster. And it got stood up. Oh yeah, certainly.
so you said it's documented already on BMC.
Yeah.
Stuff that way.
Yeah, so it's not out of the box, but it's not off the chart as far as a level of difficulty to get custom plugins into containerized environments. Yeah.
Is it supported in SaaS?
I'm sorry?
Supported in SaaS.
So I can tell you, yes, my plugin is available in SaaS on at least 4 different customers that I'm familiar with that needed REST capabilities that the out-of-the-box REST did not provide. I provided BMC with the proper jar files and they created an image and it is deployed on at least 4 customers that I am personally aware of.
But you'd have to go through the change process in order to get that added to your.
Certainly, yeah.
John had a question.
Yeah, so if you double click on any one of these, you've got a whole table. Could you hand type in all of those fields?
I don't, so yes, you could,
No, I know you can.
but none of that is read-write from a Kubernetes perspective.
Yeah, no, like just double click on one, you'll have a whole table with like 100 fields on it. Like, what if we create all those 100 fields?
Did you build all these as
Yeah,
custom
like-
forms? Is what
Look
it's
at that,
asking.
root items, metadata, label, role. That's like every single.
So this record is not a read-write record as you expect in Remedy. This is not a record that I could just hit save on
Yeah.
and expect it to update the source.
Yeah.
Okay. All of this information was not input manually by anyone.
Yeah, no,
There was
I'm like
the,
looking at the actual remedy table. It's like a virtual table. It's just being
Yeah.
created on fly. Okay.
Yeah. It's the way my RESTful plugin works is it you create a vendor form against definition. And when you perform a query against that vendor form, it makes the REST call out to whatever you define as the source is, returns the information and creates entries in a cache table that are displayable in the UI.
So then in your application, you just choose to put these 15 fields on the right, and then those fields are first, and then these just follow by some.
These are all the elements that came back from the Kubernetes call.
So if Kubernetes added a 108th field, it would just naturally just show up.
You'd have to go into Dev Studio, or you'd have to reconfigure the RESTful configuration, say this is an additional field for this REST
So it's not
service.
dynamic fields, like if I return 3 this time, I get 3. If I return 12 next time, I get 12.
It's when I designed this, I defined a contract that doesn't exist in REST. SOAP has a contract that says when you make this call, here are the elements they're going to return. SOAP doesn't have that. So in this plugin, I basically defined it so that you say, this is my call, and these are the fields that are going to come back. I built an auto generate feature that allows you to make the call and read all the fields that come back, generate those as fields. Then you go into Dev Studio, you add all of the fields into the form in Dev Studio, you build them out, you lay them out however you want, you hit save, and now you can access them as.
Got it. So you basically have a generator.
Yeah.
Does it all. Because I was like looking at that. Oh my God.
No, you would not create all of
Right.
this. In fact, this doesn't even allow you to create any of it. There's a special vendor form that I have defined for both of these, for these 2 fields right here. I've got RESTful records that are defined as performing a patch call to the appropriate URL and providing a body that contains the appropriate values that are changing replica from whatever the current value is to whatever you specify. That patch call is what makes the call into Kubernetes. The rest of them are GET calls that pull information out of Kubernetes to display this list. And I am over time. I apologize.
And we're not surprised.
LJ
Or
doesn't know how to
disappointed.
stop talking.
Any other questions? Anyone on Zoom? Okay. Great. Thank you very much, LJ. Great presentation. And I will go ahead and stop the recording.
One additional thing, this application is in a zip file on the shared drive that Lenny is giving everybody. So this application, all the data necessary to use the application as far as the plugin is concerned and everything like that, the presentation, all that is out there on the website.
Great, thank you.